Hi everyone. This week we'll be talking about correlations and scatterplots. Let's start by talking about the meaning of the word correlation. In statistics, a correlation is a relationship between two quantitative variables. In other words, a correlation is a relationship between two variables like age and income, or hours of exercise and hours of sleep. There are two types of correlations. A correlation can be a positive correlation or a negative correlation. Let's go over the difference between a positive correlation and a negative correlation. A positive correlation is a correlation in which a higher value of one variable typically goes along with the higher value of another variable. In other words, a positive correlation is a correlation in which two things typically go up together. An example of a positive correlation might be commute distance and commute time. When a person's commute distance goes up, the person's commute time usually goes up as well. So those two variables would be positively correlated. A negative correlation is a correlation in which a higher value of one variable typically goes along with a lower value of another variable. In other words, a negative correlation is a correlation in which two things typically go in opposite directions. An example of a negative correlation might be commute distance and hours of sleep. When a person's commute distance goes up, when a person's commute distance goes up, the person's hours of sleep usually goes down because the person has to get up earlier in the morning. So those two variables are probably negatively correlated. In everyday life, a positive correlation is usually called a direct relationship, and a negative correlation is usually called an inverse relationship. So those are two other ways of saying these two terms. Now let's go over some examples of positive correlations and some examples of negative correlations. On this slide, we have some examples of possible positive correlations. I said the word possible because I don't actually have any data with me to back these up. These are just examples of things that should be positively correlated based on common sense. It should be true that people who spend more years in school earn higher incomes. So this first example should be a positive correlation. I believe that it's also true that people who study more hours per week have higher GPAs on average. So the second one, I believe, is also a positive correlation. People who work more hours per week earn more money per week on average. So this is also a positive correlation. Also, I said earlier that a person with a longer commute distance typically has a longer commute time. So this is also a positive correlation. People with longer commute distances also typically have more money being spent on gas. So this is also a positive correlation. And finally, larger houses typically cost more. So the size and the price of a house are positively correlated. Now let's go over some examples of negative correlations. These are some examples of possible negative correlations. People who have longer commute distances probably get less sleep on average. So this would also be a negative correlation. People who live in hotter areas typically spend less money on heating. So this is a negative correlation. It's probably true that people who take more units in school have less free time per week on average. So this is also a negative correlation. Larger cars typically get lower miles per gallon because they use up more gas. So this is also a negative correlation. And it's also probably true that people who walk a larger number of miles each week tend to spend less money on gas per week. So this fifth one is also a negative correlation. Now that we know the difference between a positive correlation and a negative correlation, let's talk about how a person can look at a correlation in a set of data and find out what type of correlation the data is showing. If a person has collected a set of data, and the person wants to know whether the data is showing a positive or a negative correlation between two variables, the person can create a graph called a scatterplot. And the scatterplot will tell the person whether data is showing a positive correlation, a negative correlation, or no correlation at all. This is an example of a scatterplot. In a scatterplot, each dot represents one person. So this would be person 1, this would be person 2, this would be person 3, and so on. Each dot shows a person's values on two variables. So this dot right here is showing a person's value on the x-axis down here and the y-axis over here. I believe that the x-axis is a happiness rating from 1 to 10, and the y-axis is annual income. So this dot is showing the first person's happiness down here and income over here. And I said that the scatterplot tells you what type of correlation the data is showing. And I'll explain how to look at the scatterplot and find out what type of correlation it's showing you. If the dots rise from left to right, like they do here, then the data is showing a positive correlation. So this scatterplot right here is showing a positive correlation between happiness and income. If the dots drop from left to right, like they do here, the data is showing a negative correlation. If the dots drop from left to right, the data is showing evidence that the variables are negatively correlated. If the dots don't rise or fall from left to right, then the data is showing no correlation. If the dots are just a rectangle like this, or a blob that doesn't rise or fall from left to right, then the scatterplot is showing no correlation. So overall, if the dots rise, the data is showing a positive correlation. If the dots drop, the data is showing a negative correlation. And if the dots stay level from left to right, the data is showing no correlation. I just wanted to look at a couple more scenarios with you just to show you how a scatterplot can show you a correlation. So this first scenario is a scenario I just made up. Let's imagine that we're collecting a data set to look at the correlation between income and happiness. We collect data from a random sample of 15 people, and we ask each person, how happy are you from 1 to 7, and what is your income? If we did that survey, we would end up with 2 columns of data, like this right here. The happiness ratings would be in one column, and the incomes would be in another column. And then we would create a scatterplot. In the scatterplot, each dot would show a certain person's happiness and income. So one dot would show the happiness and income of person 1. Another dot would show the happiness and income of person 2. And then the next dot would show the happiness and income of person 3. If I created a scatterplot with this data set, it would look like this. So if this was our scatterplot, we would say that our data is showing a positive correlation between income and happiness. We would say that our data set is showing evidence that the higher earners tend to be more happy on average. This is just a scatterplot that I made up. It's not a real data set. Now let's imagine we're doing another survey in which we collect a set of data to look at the correlation between commute time and hours of work. We're imagining that we're doing a survey in which we ask a group of people, how many minutes does it usually take for you to drive to work, and how many hours of sleep do you usually get each night? And these are the answers to the survey. Let's create a scatter plot of this data set and see what the data shows. So this is the scatter plot of the data set I just showed you, and we can tell that the data has a negative correlation. In our data set, the people who are commuting longer each morning are getting less sleep, typically. Now let's move into our next point. The next point is a scatter plot also shows the strength of a correlation in the data set. Not only does a scatter plot tell you if the correlation is positive or negative, it also shows the strength of the correlation. In other words, it shows how consistent of a relationship you have in your data set. If the line in the scatter plot is flat, in other words, if the dots aren't rising or falling from left to right, there's no correlation, meaning the correlation has no strength at all. But if there is at least some correlation in the data set, meaning if the line isn't completely flat, then the correlation is stronger when the dots are closer to the line. And I'll show you a few examples of this point. Here, we have a positive correlation in which the dots rise from left to right overall, and the dots are kind of spread out far away from the line. They're not hugging the line very closely, so this would be a weak positive correlation. Here, the dots are following the line much more closely, so this would be a stronger positive correlation. And if the dots are perfectly lined up on the line, then you have a perfect correlation in your data set. This would be a perfect positive correlation. A positive correlation can't get any stronger than this. Now let's look at a weak negative and a strong negative correlation. We have a negative correlation in this data set because the dots are falling overall, and the dots aren't very close to the line. They're kind of spread out, so this would be a weak negative correlation. If we move the dots in closer to the line, we would have a strong negative correlation. And if we put all of the dots perfectly on the line, we would have a perfect negative correlation. A negative correlation can't be any stronger than this. This is a perfectly strong negative correlation. So overall, if the line is flat and the dots don't rise or fall from left to right, then there's no correlation at all. It doesn't matter how close the dots are to the line. But if the line in the scatter plot is not completely flat, and there is a correlation in the data set, then the correlation is stronger when the dots are closer to the line. Let's look at some examples of possible weak correlations. In other words, let's look at some examples of things that should be positively correlated overall, but the relationship isn't very consistent. Age and income is probably a weak positive correlation because it might be true overall that older people typically earn higher incomes because they have more experience and they've been at their uh, job longer, but this there's definitely a lot of exceptions to this. It's definitely not something that's true for everyone, so this would be probably a weak correlation. Also, it might be true in general that people with higher GPAs in elementary school typically have higher GPAs later on in college, but this is probably not true for a lot of people. It's probably not a very consistent relationship. There's probably a lot of people with high elementary school GPAs and low college GPAs, and there's probably a lot of people with high college GPAs but low elementary GPAs. So this probably isn't a very consistent correlation. Also, I was thinking that there might be a weak positive correlation between the number of units that a person takes in college and the amount of money that the person spends at the student union each week. I was thinking that people who take more units are typically on campus more hours per week, so they might typically buy more food on average, but that's probably not true for a lot of people. There's probably a lot of people who spend many hours on campus per week, but don't spend money on food at the student union. That's because a lot of people probably take their food to campus. So this is probably a pretty weak positive correlation. Here's some examples of some possible strong correlations. So amount of time studying per week in GPA is probably a strong correlation because people who study more probably earn higher GPAs pretty consistently. They're probably so it's probably a pretty consistent relationship. So it's probably a pretty strong correlation. Also, people who take more units in college probably have less free time pretty consistently. There probably aren't that many people who are taking 5 classes in a semester and have a lot of free time. So this is probably a pretty strong correlation. I think these other two are probably also pretty strong correlations. Let's look at this last one. People who commute a long distance to work spend more money on gas pretty consistently. There aren't many people who have long commute distances who don't spend much money on gas. So this is a pretty consistent correlation. So it's a pretty strong correlation. So overall, a weak correlation is a less consistent correlation. It's a correlation that's maybe true overall, but not true in many cases. And a strong correlation is a consistent relationship. It's a relationship that's generally true most of the time, without many exceptions. And now that we know the difference between a weak correlation and a strong correlation, and we've looked at some examples, let's now talk about the idea of a perfect correlation and go over some examples of perfect correlations. A perfect correlation is a correlation in which, it's a correlation that's perfectly consistent. It's a rule that's true 100% of the time. So these are some possible examples of perfect correlations. Let's look at this second example. When a person's hours awake per day goes up, and a person is awake more hours, the person's hours of sleep always goes down. A person, for example, a person who's awake 20 hours per day is always asleep 4 hours per day. A person who's awake 10 hours per day is always asleep 14 hours per day. So these two variables are perfectly correlated. You can't have a change in one without a change in the other. This third one is also a perfect correlation. If you look at all of the runners in a certain race, the runners who are running faster always have shorter times. So these two variables are perfectly correlated. There's a perfectly consistent relationship between them. So now so far in this lecture, we've talked about the meaning of a correlation. We've talked about the difference between a positive and a negative correlation. And we've looked at how you can tell if a correlation is positive or negative in a scatter plot. And we've also talked about the strength of a correlation and the difference between a weak, a strong, and a perfect correlation. So this covers everything for this lecture. You can just let me know if you have any questions.